afternoon, everyone, or good morning to our West Coast attendees. I'd like to welcome you to today's webinar entitled Visibility and Analytic Strategies for Virtualized Data Centers. My name is Mark Johnston, and I'm with Telemetrics, and I'll be your host for today's presentation. I'd like to introduce our expert speakers today. We have Jim Root. Jim is the Chief Information Officer for Lake Emergency Medical Service, Inc. in Florida, and has been the CIO there since April of 2006. Mr. Root has served as Product Manager and Senior Networking Engineer for Coma Technologies for 10 years before joining LEMS, and he received his CIO Officer designation from Florida State University and his Bachelor's in Business Administration from the University of Central Florida. Roger Yao is also with us. Roger is a Senior Architect at Wheela, and he's built up a prominent reputation and a record in developing innovative computer networking technologies. He acted as a key founding member at Air Magnet, and they merged with Fluke Networks in 2009, where he continued to be a senior technical leader for the wireless business unit at Fluke. He holds a master's degree in electrical engineering from Cornell University and a bachelor's degree in information technology from Nanjing University of Science and Technology. Today we're going to be discussing the impact of next-generation architectures and visualization on data center operations. This technology has driven tremendous cost and efficiency improvements, but has made the old ways of managing your network and applications obsolete. We're going to take a look at how Jim's team has overcome these challenges and now has a clear picture of applications, network, and virtualized infrastructure. Finally, if we have some time at the end, we'll take a few questions. So at any time during the presentation, feel free to submit any written questions you have, and we'll compile them during the presentation. So perhaps, Jim, can you tell us a little bit about any data center technologies and trends that you see that our attendees should pay attention to?
Well, Mark, in public safety especially, we've got quite a struggle in looking at new technologies and trends and figuring out how to make those meet not only our current needs, but some of the future ones, and doing that really within restrictive or competitive budgets. Public cloud services have helped a lot of government agencies relieve that tension by providing advanced infrastructure capabilities at an OpEx level, rather than taking a hit to capital, which always seems to be our governmental problem. However, we have some unique critical workloads that don't currently fit within a public cloud infrastructure, and for a variety of reasons, right? So we have life safety issues involved. Our workloads are like computer-aided dispatching, where we're actually actively assigning units to calls and dispatching those services to the correct ambulance or fire engine. The call-taking scripting, so when you call into 911, making sure that the questions that we're asking the caller and the responses that we get back generate the right response for their need. GIS and mapping, patient billing, electronic patient care, record management. So we have all these really critical workloads, and we began investigating technologies like hyperconvergence. And in that, the ability to do software-defined net storage, and then also software-defined networking. We really saw those as opportunities where we could get some of these advancements that were being made into the public cloud infrastructure, but bring it into our enterprise line of business applications. About 5 years ago, I was introduced to hyperconvergence at a conference, and I decided right then and there that it was going to be part of our long-term capital plan. This hyperconvergence allows us to bring that scaling of compute and storage as my needs grow, but I can keep that process rather simple and very cost-effective to us. Same thing goes for software-defined networking. That is going to support the storage as well as the network traffic, and we needed simple configuration, and we needed path resiliency through logical switching fabrics, and those were key features for us.
Great, thank you. Well, what are some of the business and technical challenges facing data center IT operations today?
Well, I think a joke in our organization is Arthur C. Clarke's third law that any sufficiently advanced technology is indistinguishable from magic. So our users typically will call us magicians to some extent. And I think for most of us managing any infrastructure or operation in today's complex computing environment are faced with just that. And if you doubt that, go try to explain hyperconvergence to an executive management team so that they understand it. The problem is that that same technology really can't appear as magic to us as those managing that infrastructure. We have these great virtualization technologies, the magic, and then poof, suddenly we have these gaps in our visibility from what we used to be very keenly aware of when we were in that standard physical infrastructure of compute, network, and storage. That first gap that you can see there is the visibility problem that's between our physical and virtual infrastructures. So with the advent of, for us, VMware in our environment, we suddenly saw the separation, between the hypervisor and the physical infrastructure, and it created a problem for us in making sure that we really were understanding what was happening between those layers. And then the second gap is that visibility problem that we have between the virtual infrastructure and the applications that are running on top of it. Unfortunately, these aren't too different from the gaps created by our organizational silos that we built when we were using more conventional infrastructures, like with networking team and a storage team and a server team and your applications team. And then we collapsed our physical infrastructure, but when there's a problem, we still need the tools and logging and everything else to go along with that to see what's happening there. Then we look to the same within our hypervisors, and finally we're scouring logs and configurations and applications for our clients to get to the bottom of something. We have a lot of available data points, but we end up feeling like on our team, we've got to have a Sherlock Holmes helping us work to get to the bottom of a poorly performing app in one of our critical departments.
Okay, thank you. Well, how would you advise IT operations tackle these challenges?
Well, when we began searching for monitoring tools, we wanted some key things. First, we had to be able to see the whole picture from within the tool. That meant from each level of the physical infrastructure all the way to, in our line of business, we call it the butt in the seat. We had to be able to fully analyze the east-west traffic that was going between VMs and their applications, and what was happening at that physical infrastructure layer. Next, we had to have a software-based solution that we felt was easy to deploy. I really didn't want to get into a specific hardware-based appliance or some other hardware solution that really tied us into making a physical change when we needed something new. It was also pretty much against agent-based solutions, if I could get away with it. I was pretty tired of OS changes causing an agent issue, and then vice versa. We had to change the agent, and now we had to make sure whether that we were on the correct patched version of the OS. And frankly, I still am. It had to be bulletproof. Any solution had to be completely non-disruptive in normal operation. And then don't forget the upgrade process. It had to do the same thing when we got to that point as well. And of course, it had to do the real work. It had to be able to pinpoint the problem with as few steps as possible for me. In fact, I was looking for the bright flashing red light, right, where I could see the root cause, boom, click, there it is. And finally, it should be data rich in information, that can help us tweak performance. And I don't want to be myopic to just the problem, but also be able to plan into the future, if we have major changes within line of business applications or the mix of those applications across our infrastructure.
Okay, thank you. Tell us a little bit about Lake EMS and your specific infrastructure environment.
Well, like I mentioned before, about 5 years ago, I was introduced to Nutanix, and at the time, it was very, very new, but I completely understood where they were going with hyperconvergence and why this was going to be a really great fit with, especially within emergency medical services. We were able to last year purchase two Nutanix nodes that you can see in there, along with a Brocade 10 gig network that's on their VDX platform, so that we could support this convergence of not only the compute but the storage, and be able to provide the backbone for that. And that's moving off of a traditional SAN with fiber channel switches and standard HP servers and the like in our environment. And in fact, you can see in that picture there's space that we filled with fillers because we were able to consolidate so much of our infrastructure using the hyperconvergence technologies. We're a VMware shop, and we have been for many years. We feel that there's a lot of value in vCenter and ESXi. We've used them across all of our virtualized environment. In fact, we're outside of some fax servers, 100% virtualized across 2 data centers. We run the aforementioned applications for EMS and across those as well. And in addition to that, we have the typical enterprise applications like Exchange, many SQL databases, help desk software, and client management software in there as well.
Thank you.
Mm-hmm.
Well, then, why don't you tell us a little bit about the challenges you faced and what happened after you implemented the Wheeler solution?
Well, quite simply, it was difficult for us to know exactly what kind of problem we had, and even when we had that problem, when we're relying on our users and their individual complaints to try to get to the bottom of a problem. And then connecting all of that data that's loosely distributed among applications and hardware and the virtualization platform. And I was introduced to Wheeler as we were looking at different tools on the market, and we decided to give them a try in a demo environment. And within the first week of operation, Wheeler delivered right off the get-go. We have a patient billing system that we have long known has intermittent performance issues. And in that first week, Wheeler was able to correlate problems that we were having with an advanced user that had been running crystal reports on this intermittent basis, and the crystal reports were unfortunately poorly written, and they were directly impacting the database, which was then directly impacting the end users in this standard SQL client user environment. We were able to get him to schedule those reports. It happened to be our COO, unfortunately, and we were able to get them to run those at a more appropriate time and prevent the application performance issues that we were seeing. And then afterward, we were able to verify that using Wheeler as well. A week later, we uncovered an issue with our mail archiving solution we didn't even know we were having. It was spiking CPU consumption when it was doing these particular indexing operations. We were able to take the information that we gathered from Wheeler, send it over to our vendor. Our vendor was able to provide new code, and in under a week, we had our mail archiving solution fixed. So, why did we look at Wheeler and really feel that it was a good solution for us versus like other applications? Well, Wheeler really gave us the whole picture within the default dashboard of the tool. But then I could go further, and I had the ability to fully analyze my east-west traffic. That's my VM to VM or VM to app, end user communication within a couple clicks. It was super easy to deploy. I frankly was shocked. I mean, in under 45 minutes in a conference call, we had a complete deployment in our environment, and we were gathering data before we even hung up from the call. In fact, we had to kind of not look at the data until we had got enough in there, but within the next day we were already looking at the data anyway. So we did our first upgrade a month later. It was in the middle of the week, a weekday, in about 30 minutes. We had no disruptions. We had no performance hits, and the users had no idea we were doing any of this in the background. And frankly, Wheela did exactly what they were advertising it was supposed to do. It delivered that single pane of glass, basically, into performance monitoring of our hyperconverged environment. And it has great analytics in there. So, besides just looking at that first screen, you can do some pretty significant deep dives, and it really just made that process of identifying an issue and resolving it very quick.
Great. Well, can you tell me a little bit, Jim, without necessarily throwing anybody under the bus, before we go to the demo, can you tell me a little bit about what other kind of tools you looked at and what the differences were that made you decide on Wheela?
Well, I can't speak to specific applications.
Yeah, I don't want to talk about specific companies, but in general.
But in general, we looked at several that had some agent-based components to them that it made it a little more difficult in the deployment aspect. They didn't necessarily not deliver in the data analytics point, but we wanted to be sure that what we chose didn't have a level of complexity outside of that first install with the vendor on the phone. And we actually looked at whether or not we could home grow some of these things by tapping into the data sources that we have at different levels and then tying those into a single logging mechanism. But that was way more problematic than what my staff really could support, and it really didn't have a good long-term strategy for us. And Wheela fit the bill in meeting some of those strategic objectives.
Well, thanks very much. I appreciate that, Jim. Maybe now we could turn and Roger can give us a brief demonstration of the Wheela product and show kind of how it works and demonstrate some of the things that Jim was talking about in his application.
Sure, Mark. I'm going to take over. So before I jump into the lab demo, I want to quickly go through the big picture, which is Wheela architecture, right, to give you guys the overview. So as you can see, on this slide, all the gray components are your infrastructures, virtual or physical, right? And the first component Wheela deploy in your environment is called Virtual Smart Tab. We call it VST. Basically, it's a small VM we deploy on each host, and this to cover all the hosts in your data center. Basically, you have to deploy one VST for each host, right? So this VST is sitting in your virtual switch and doing the deep packet inspection. From deep packet inspection, VST collect all the TCP layer information such as network round trip time, retransmission, zero window, reset, that sort of good information. On the top of that, VST also can identify all the protocols and applications running in your data center and measure its performance by calculating the application response time. And more importantly, VST collect all the transaction detail information such as client, server, what's the reply, what's the request, right? And all those information later gets sent into another piece we deploy in your data center, which we call Virtual Information Controller, VIC, right? So VIC collect the application and network metadata from VST, and also it collect other information from other data sources, like the second data source, which is your virtualization management software. In VMware case, it's vCenter, right? From this virtualization management software, Vic collect all the structural information like host, cluster, VMs, data stores, and create the topology, right? And since we got all the entity and objects in your data center, VST also query all the important statistics on those objects like CPU memory usage, ready time, storage latency, all that sort of good stuff. And the third data source is coming from your physical infrastructure. Vic does SMP query to you top of rack switches and sucking that physical information as well. After Vic collect all this information and digest all those information, they are gonna be forward to the third piece we have, which we call management and analytics system, right? So this piece could be the SaaS mode or on-prem, depends on which one fit you need, right? This component is where Hadoop services is sitting on and all the application infrastructure analytics sitting on. So later you can open the web UI session to see all the visualizations and analytics will provide to you. So after talking about the architecture, I'm going to jump into the live demo. Very quickly, let me bring up my browser. Make a little bit bigger.
It's good.
First, I want to make sure you guys can see this page, colorful page, right? Okay.
Yeah.
So yeah, as I said before, after you log in the web portal, right, the first page you hit is this dashboard. So the dashboard is the place where you can see your data center's health at a glance. First, I want to talk about the timeline sitting on the top of the dashboard. Obviously, the horizontal axis is time, but the vertical axis can be divided into 5 rows, right? Each row represents one aspect of your data center's health. From top down, it's application performance, CPU health, memory health, storage health, and network health, right? And as you can see, there's a time window on this timeline, right? Which you can do all kinds of operation against, like move it around, right? You can expand it or narrow it. And as you can see, whenever you touch this time selection, there's 6 widgets below the timeline got refreshed, right? And 5 of them are color view widget. Its applications, respectively, its application performance, network health, CPU health, memory health, and storage health. Let me explain to you how to interpret the color wheel. First, let me expand this CPU color wheel where you can get a bigger view. So at the core of the color wheel, it's your data center. Going outward, it's your cluster layer, host layer, and VM layers, right? As you can see, we color code each object, each VM cluster or host, by tracking the key metrics and automatically generate the baseline against those metrics, right? By using the baseline, by comparing the baseline to their current value, we can, color code either VM or host or cluster, right? For some metrics, like, CPU ready time, the automatic auto line may not apply perfectly. We use the, best practice threshold to do the color coding. So, there's another color wheel there's another widget called application server alarm widget, which is empty right now, right? This is the place where you can capture all the application degradation and do infrastructure root cause analysis, right? So after learning all these basics, I'm gonna demonstrate to you a use case, right? Which is coming from a, admin system application admin type of person perspective, and he want to capture a application performance degradation and troubleshooting to find out the infrastructure root cause, right? The story starts from the timeline again. So the way to use timeline to capture this kind of issue is to follow the red or orange. Like this period of time, which is pretty colorful. I move my time selection over, and you see there's one alarm, fall into this time period. And you can expand this widget to see the details of this alarm. So basically this alarm telling you, okay, you have application performance degradation on the VM called Oracle 11G, and the service is MySQL service, and your current application response time is 300 plus millisecond, which is way above than your baseline. And we tell you when this alarm got triggered. How to find the root cause? You can just click on this alarm, and it will bring you to this root cause view. So on the top of the root cause view, you see two trending charts. The first one sitting on top is the trending chart for application response time. And the second one is for transaction volumes, right? As you can see, we automatically select this problematic time period where the ART, application response time, is above the baseline. That's why you see the red color bar over there, right? Something wrong over this period of time. And below it, we use the small window, three small windows, CPU health, memory health, storage health, to tell you, which one is your infrastructure problem, infrastructure root cause. Here we are pretty confident. We say, okay, you have no problem with your CPU health, no problem with your memory health. The primary reason is your storage health. By reading the text, MySQL service is actually impacted by long read latency at VM layer, host layer, and data store layer. We allow you to validate this conclusion. You just need to do another click on this storage window. It will bring you to the next layer. So here, we lay out the storage statistics as three layers. Horizontally, right? First layer, VM layer, which is a virtual layer. Then host layer, physical layer. Then we go to the logical data store layer. And for each layer, we use 4 columns to respectively represent read latency, write latency, read IOPS, and write IOPS. As you can see, the 3 window, the red window on the left-hand side, capture my attention. Right? Basically, it's telling me your read latency at all 3 layers are not as good as expected. And since it's related to read latency, you really want to know who are competing for the IOPS, the read IOPS resources at this moment. Right? To find out that information, you just need to move your mouse over to either host or data store, read IOPS, pick a red bar, and one click, you are going to see a breakdown list of all the contributors to the IOPS contention. So in this way, you get more information about the nature of the storage issue and how to address it. And to find out whether your storage issue, what kind of transactions are impacted by your storage issue, you can go back to the previous view and focus on the worst transaction section at the bottom, right? Here you see all the worst transaction per minute, right? We show you the application response time, we show the client, server, service, what's the request, what's the reply, for you to understand the nature of the impacted application and transactions. This is my first use case. As you remember, we have gone from the application degradation to infrastructure root cause. So what if you are a infrastructure type of person, administrator type of person, who really want to take the other way around and start from infrastructure problem? WILA can provide that function as well. So as you know, in the market nowadays, most of the IPM tools can give you a lot of infrastructure alarm by sending you alert, emails, or recommendations. But facing the overwhelming information, you don't really know which one is more important in terms of the application influence, right? WILA can fill that gap. Let me show you how WILA can do that. So to do that, I'm going to focus on a different period of time, which is this period of time. There's a lot of red for memory health, right? And this time I'm going to still focus on the CPU health. As you can see, the CPU health color wheel become very colorful, especially the outer cycle. There's 2 orange sections to get a better view. Expand it. And as you can see, these two orange VMs are WebLogic 11G and Oracle 11G, right? To see more details about these two VMs, we can sort by health score in the table view. Then these two VMs pop up at the top. By reading the statistics we provide, you realize the CPU ready time is pretty high on both of them, right? And you wonder which CPU ready time affect your application. Willa provides you that information. You just need to do one click on the first VM. You see there's 4 services running on the Oracle 11G VM. And fortunately, these 4 services are pretty healthy at this time, which means this one may the CPU ready time, it may be an issue, but it haven't impact your applications at this time. So you don't have to worry too much at this moment. But if you look at the second VM, WebLogic 11G, and there's 2 services, HTTP and RSS. HTTP service is color-coded as yellow because we are telling you this HTTP service performance is adversely impacted by your CPU ready time. This is the way you realize, okay, this CPU ready issue is more important, more urgent. To validate the conclusion, you can always click this red service, HTTP. It will bring you to the root cause view to see the details. Like the trending chart show at the top, the application response time is not perfectly healthy, and we point the primary reason to CPU health. If you dig in, you are going to see all kinds of CPU statistics, right? For you to see the for you to see the more detailed statistics. But I don't have to repeat over here. And again, since HTTP service transactions, you can see all the worst transaction during this period of time. You can see more detailed information about request and reply. So you know what application and what transaction are impacted by this high CPU ready issue. Okay, after this, I'm going to quickly go through some other view where Willa can provide, we can prove Willa can provide the full stack stability in your environment. First, let me focus on the application analysis. This is the dependent service view we created for multi-tier application. So you can create this kind of chart for any VMs, any service, right? As you can see in this one, there's the VM call application LB002, right? And it's the first tier. Behind it, there's 2 WebLogic server, right? Behind the 2 WebLogic server, there's a bunch of database server. So the beauty of using this kind of dependency map is very quickly, you can identify the bottleneck of the multi-tier application. For example, this dot Oracle 11G is orange, right? And this link from WebLogic to Oracle 11G is also orange. And you can move your mouse over to this bottleneck, right, to see what kind of service is running on top of this link. As you can see, SSH service and my SQL service is running on this link. And unfortunately, my SQL service is not very healthy, right? This is the bottleneck. I want to see why this is the bottleneck. And what's infrastructure root cause? Is there any infrastructure root cause causing these problems? You can do it over here as well, right? But by clicking this service again, you go back to the root cause view to see the conclusion, right? To see all the detailed statistics. We don't have to repeat over here. And the next view I'm going to show you is network analysis. The first chart is the flow analysis chart. So here is the place you can see what kind of application, what kind of traffic and application is running in your data center at a glance. Pay attention to the right-hand column, which is classified. So here are the protocols running in your data center. And also, we divided your data center into multiple layers, right? VM layer, port group layer, and DV switch layer, host layer. We use the ribbons to connect different layers to show you how the traffic flows through your data center, right? For example, at this moment, looks like most of my traffic is my SQL service, right? And this two VM, WebLogic 11G and Oracle 11G, contribute to the most chunk of the MySQL service. And this two VM belongs to port group called Walmart, and this Walmart port group is on DV switch 2, and DV switch 2 is on host 5. And also, we color code VMs. If you move your mouse to this orange VMs, you see all the network statistics like network response time, failure retry, your virtual packet job. Obviously there's something wrong on these VMs in terms of the networking statistics, and we allow you to drill down further, right, to each services to see, how much network anomalies each service has on this VM, right? If you identify an important service, right, on this VM, and there's some network problems, you want to dig into the packet level, Willa can provide you to do so. Here, for example, HTTP service is not very healthy. Next to the HTTP service, there's the small icon. Here, you can click on this button, then we automatically collect all the traffic on this VM, on this service, and a particular VST gonna build up GRE tunnel and forward all this packet to a internal GRE device or external GRE device for you to do the deeper packet analysis. The next one I'm gonna quickly go through is the storage analysis view. So here, like the network flow analysis view, this is the place to show you how your IOPS flows through your data center, right? Multiple tiers in your data center, data store, host, VM, the disk, right? The width of the ribbon and bar is decided by the IOPS volume. And we color code each VM or host by read-write latency, right? For example, this one is orange. We drew your attention over here, and you will realize the read-write latency is not very healthy. And again, you can see whether the HTTP service or TCP service or Postgres service is impacted by this storage latency issue or not, right? You quickly can do that over here as well. So I'm gonna do a quick time check. How much time do we have? Okay, we still got some time. Let me keep going for a moment. CPU analysis, right? We visualize your CPU provision and usage in this chart. Like you can see, the biggest circle is your data center, right? Inside your data center, there's 2 clusters, and inside each cluster, there's several hosts, and inside each host, there's a bunch of small bubbles representing VMs. So by looking at the thickness of the circle, the CPU usage, right? Which means the more solid a circle is, the higher the CPU usage it has. And we also draw your attention to the yellow or orange circle because we color code VMs by high CPU usage and high CPU ready time. So here you can quickly identify this WebLogic 11G, which have the high CPU ready time. And here also you can do the root cause analysis on the HTTP service, which is adversely impacted by the CPU ready time. So tree view, same concept, but different way to present the CPU picture. So as you can see, data center layer, cluster layer, and host layer. And you can expand host layer to see VMs and services. For memory, similar thing, right? Circle view, tree view. And another feature I want to highlight is the critical resource view, right? This is the place, imagine if you have over 100, 300, even 1,000 VM in your data center. You don't want to really focus on every VM, right? You want to pick up the important one and to keep a closer eye on it. Here's the place you can do it, right? You can easily add an important VM on this view, and we generate the time matrix on the top, which reflect the health of this important VM group. So under each VM, we provide the horizontal view, right? We show you all the usage trending chart, Is there any alarm triggered? What's the services running on it, and what's the dependency maps looks like. For this one, it's pretty easy, but for this one, this is more interesting, right? And other than that, we'll provide all kinds of report for you to monitor your data center from a long-term perspective. Like you may realize, at the dashboard, that is a good place for tracking your data center health in 1 day, 2 day. But to generate a longer perspective view, you come to report. You generate a weekly report or even monthly report, right? There's 4 types of report focused on application performance, VM resource usage, host resource usage, and service performance. I think I already almost covered the important feature of Willa. I'm gonna stop here, for some Q&A. Hey, Mark.
Thank you, Roger.
Yeah, Mark.
Yeah.
Take over the control.
Great. Yeah, thanks very much. Well, I've been watching the questions monitor. There's a few of them that have come in, so maybe we'll cover a couple of those now. First one that we got was how will Willa interfere with or impact or otherwise change the workload of the data center, and what kind of risks are involved in deploying Willa?
Good question. Like I said before, during the architecture, Willa is completely doing the passive monitoring, right? We collect all the network information, application information by doing the passive monitoring. And Willa does not, intercept any packet. So the only thing that we're doing is this passive sniffing. That's pretty safe. And also, all Willa component is deployed as OVA file, right? It's a separate VM. It's not part of your workload VM. It won't interfere with your working servers or workloads VMs, right? So also you can do all kinds of protection on our Willa VMs. You can set up the limit, right, resource limit, to make it like a predefined sandbox to make sure there's no interfere between Willa component and your workload servers. Does this answer the question?
Well, I think so. I didn't ask it, but I guess it does. Next question is kind of related somewhat. The question is, how much shared resource of the host and network bandwidth does Willa consume?
On average, our VST use less than 5% CPU usage, and just 0.1% of your network, 1 gigabyte network, assuming you are using.
Okay, thank you. Next question was, I think actually Jim covered this a little bit already in his talk, but the question is, they understand that Willa is software, there's no appliance involved, but what is the level of effort required to get it up and running if you decide to try it out?
Yeah, Willa deployment simply is just a deployment of a several OVA files, right? And if customer go with SaaS mode, the deployment effort gonna be minimal, so it's require 30 minutes. You can finish everything. If the customer go with on-prem mode, the whole deployment gonna take 1 hour, roughly. Everything will be done within 1 hour. In Jim's case, everything got done within 45 minutes, like he said before.
Okay. Okay. All right. Good. And next one is let's see here. How soon after you deploy Willa do you get a successful? Do you see it in action?
Yeah, normally after 5 to 10 minutes after the deployment, you are gonna see some colored on your dashboard and other views. And to see the meaningful baseline, right? Willa require several hours, because by default the baseline configuration is 1 hour, last hour. So you do need a couple hours or several hours to build up the meaningful baseline. But everything gonna be become meaningful within several hours. That's for sure.
Okay, and we have time for one last question. The question came in, what are the features that uniquely differentiate Willa from other alternatives on the market?
Yeah, that's a good question. Actually, what makes Wheeler unique is the ability Wheeler can correlate application performance with infrastructure. Both ways. You either come from application degradation to infrastructure costs, or you come from your infrastructure anomalies to the application impact, right? So that type of capacity or ability is lacking in other mainstream IPM tools. But Wheeler can fill that gap very powerfully. Also, Wheeler, as you can see during the demo, Wheeler provide the full stack stability, over your application, network, infrastructure. It's really a full stack view, a full stack visibility for you to, get control of your whole network, whole information, a whole environment. Yeah, sorry.
Okay, so what you're saying is there are a lot of APM tools out there, and I think of APM, I think of people like New Relic and AppDynamics, and there's a bunch of IPM tools out there, guys that focus on storage, for example. But there really aren't very many products that really bridge the gap between what's happening with the virtualized infrastructure and that impact on your specific application.
Correct.
Okay, great. Well, I think I'd like to thank our panel for contributing. Jim, thank you very much for your insights. And Roger, thank you for the presentation. And if anyone has any further questions, please feel free to contact Wheeler directly at marketing@wheeler.com. Thanks very much, and everyone have a great day.